Chapter number 7, Economics of Maintenance and Spare Parts Management. See, when we were discussing about the operations management from the beginning, we were using the terms like raw materials, exactly not raw materials, input, output, and the process, and so on. Okay, put, output, and the process. When we talk about the process, we might discuss this in two angles. One is about the human working, okay, that's we call as human capital, or the other angle we can talk about missionaries. So in this seventh chapter, we are going to talk about missionaries. Okay. Just keep in your mind, you are going to buy some machinery for your home in a market, mixie, grinder, okay, else washing machine or fridge, refrigerator, else mobile phones. Okay. I don't want to go for mobile phones, okay, because when we talk about mobile phones, if there are four in your family, there'll be eight phones. Correct. So I'm not going to talk about mobile phones. Any device. Probably in your lifetime, when you talk about these four items, these four equipments, these four appliances, how many times you might have changed it? உங்களுக்கு நினைவு தெரிஞ்ச நாள் வந்து if you ask your mom and your grandma and all, they will say எனக்கு கல்யாணம் சீரா வந்துச்சு அதான் யூஸ் பண்ணிட்டு இருக்கேன்னு சொல்லுவாங்க. Okay. Mixie, grinders and all okay, but when you talk about washing machine and fridge, it definitely varies nowadays. Earlier, there was no washing machine concept, so you have to wash it by hand. That's manual human labor. We are not going to talk about the human labor here. When there is no washing machine, no issues of talking about this topic. When there is a washing machine, it was semi-automatic, then automatic, then under automatic we have top load, front load, and there is a separate machine for drying and so on. Probably in your lifetime period, you might have changed to washing machines and refrigerators. When you talk about refrigerators, definitely the family is growing bigger. We need to have a big capacity, or in 7 to 10 year period of time, you want to change the refrigerator. So you might be doing this. And this even applies for grinder and mixies. So if you check whether you're going to off change these appliances, no. Okay. If the small sound occurs, what about the சின்னதா ஒரு sound வருது என்ன பண்ணுவீங்கன்னா வெயிட் பண்ணி பார்ப்போம் 2 days or 2 or 3 days will wait. The same error or the same problem occurs, then we may call a mechanic first of all. Or if you know some idea about the washing machine, மெயினா என்ன பண்ணுவோம்னா ஒரு ஆயில் போட்டு பார்ப்போம். Okay, ஏதாவது அங்கங்க பட்டன் அட்ஜஸ்ட் பண்ணி பார்ப்போம். So you may do on your own. Else we call a mechanic or washing machine mechanic. You can also say you have to replace it every day. So the first instance, you will not go for replacement. There are some appliances which works very good for 5 years, and probably the warranty period is covered for 5 years. It works very good for 5 years. After 5 years, automatically instead of calling a mechanic, what you do? You go for replacement because the lifetime is 5 years is over. It was working good for 5 years. So talking about this one is what you call as economics of maintenance and spare parts management. Not only that one, we have to talk about spares also. Okay. So spares, sometimes we will not be changing the full equipment, we'll be changing some specific spares alone. So how are you going to manage the spares at your company, at your manufacturing? So we'll go for a broader intro, what do you mean by maintenance and other things, then we'll go for topics like this. Definition of maintenance. We can call this as some function bringing back or restoring an item. Please highlight. Two words we are going to use. I may be going word by word, okay? Because it's somewhat unique in terms. One is, we can say, we are going to bring back to the original operation, or sometimes we might be saying that we are going to restore it so that its original and acceptable condition is kept over. Okay? We are making it healthy and working. When we talk about the objectives of maintenance, we have, I think, 8 points are there. To keep all production facilities and all allied facilities also, please highlight. To keep all the production facilities and all other allied facilities in optimum working condition, that's about our operation management. That might be including building, premises, power supply system, it can be anything. We need to want the accuracy, so it should be correctly maintained. If it's not correctly maintained, then the accuracy may not be helpful. And also, timely delivery of to customers also is needed. To minimize downtime, downtime means when the machine is under repair, you have to minimize the time so that we put it to service immediately. The downtime on the coming from them. So we'll call that as time taken to, for repairing. Downtime is one making it idle. Okay. To keep the production cycle within the stipulated range. So you remember we are talking about the line balancing problem or line of balance in the cycle time குள்ள முடிக்கணும் அப்படின்னு சொல்லிட்டு. So if this preventive maintenance and other maintenance we have, this maintenance system is taking a lengthy hours. அப்புறம் line of balance வேலைக்கு ஆகாது. To modify the machine tools if needed and to improve productivity of existing machine. Yes, sometimes we have to overhaul the machine so that we can avoid the sinking of additional capital. தேவையில்லாம capital grab பண்றது. To minimize the maintenance cost and to extend. Yes, beautiful point. Sometimes this rest is needed so that the plant and machinery's life will be extended. So, depending on these objectives, we'll be working on the economics of maintenance and spare parts. So, first one will go for different types of maintenance are there. First one will go for breakdown maintenance. Okay, when you take breakdown, only when it breaks, you'll go for maintenance. So the other word or name called here is repair maintenance. So you repair the machine only after. Please highlight this word after finding the machine. Okay. So the production facility will run without much routine maintenance until it breaks down. What do you mean by routine maintenance is every week will go for a maintenance. Okay, or every month will go for a maintenance. If you talk about this in this angle, we say it's a routine maintenance. The big highlight we go for breakdown maintenance is break okay, so you're not going to schedule or you're not going to maintain a proper scheduling and all. So அது எப்போ இருந்தோ அப்போ பார்த்துக்கலாம் இந்த மாதிரி. So what's the methodology behind here is the breakdown machine. So how the process is done. The second for repair and then inspect what are the defects are there. Actually, what's the drawback here is it will be happening unanticipated. You don't know when the repair will happen. அது ஒரு பெரிய drawback இல்ல. All the machinery system is under repair at the same time. Now everything will be just to hold on. Production hours will be obviously lost. And after identifying the defect, the required repair is planned and the spares are procured to repair the machines. Reasons for non-recommendation will not do this because if you are not considering it, then the breakdown repair cost will be greater than the regular maintenance cost. So you have to follow strictly. And why we have to prefer, that's limitations and advantages and disadvantages. Why you have to prefer? Certain non-critical items whose repair and down cost are less swing. So obviously we'll go for this type of maintenance. Okay, repair ஆகும்போது பார்த்துக்கலாம். இந்த மிஷின் எல்லாம் நீங்க routine maintenance பண்ணாலும் ரொம்ப காஸ்ட்லி ஆகும். We need to have experts on this. So repair ஆகும்போது 10 நாள் 15 நாள் அது repair தேவைப்படுறதா we wait for that. அந்த மாதிரி பண்றதுக்கு better. Okay. So reason for preference and reason for non-recommendation. Recommended and not recommended. So that's about 7.1. It's all small topics. Very small topic. Shall I go to the next one? Let me finish off the theory content. Then I'll give a small time. Then you can go for the problems. I'll go for preventive maintenance. When you say preventive, it means prevention is better than cure. So before it stops, let us do some work. Okay, that's about preventive maintenance. So obviously, that's going to minimize the breakdown maintenance problem. A beautiful point. We'll be actually locating the weak parts in all here. Okay. So we'll check which parts are not working well, which parts are working, then we'll check on that and we'll anticipate, then we'll do it. Provide some regular inspection also, which means you are going to locate the weak parts, means we'll check which are the parts working and not working, which are the weak parts. So you have to regularly inspect them. And if there are minor repairs, then you can do it immediately. சின்ன சவுண்ட் வரும்போதே பார்த்துரும் இதுக்கு பெரிய சவுண்ட் தான் வெயிட் பண்ணோம் so that you can reduce the unanticipated maintenance which is not possible in the first earlier case. Breakdown maintenance is not possible. Here in preventive maintenance is possible. So that's why it's also called as planned maintenance or scheduled maintenance. So it varies plan to plan. You cannot have one single schedule for all the plants, all the machinery. It very plan to plan, but it's actually costly. Because you need to have the experts or you need to have the experts team regularly appointed. Okay, so it's somewhat costly. So you have to maintain records like both labor, materials used, what are the spares needed, and you have to value what's the work done by the department and so on. So one of my cousins, he is an engineer working in L&T. He has a very big team, almost 100 plus engineers are there to check only this preventive maintenance. ஓகே இப்படி யோசிச்சு பாருங்க ஒரு இன்ஜினியருக்கு மாசத்துக்கு 50,000 ரூபாய் சம்பளம் போட்டாலும் 100 engineers ஒரு வருஷம் ஃபுல்லா per annum cost இப்போ வகுப்பா தெரியாது preventive maintenance காக மட்டுமே. So that's why this is costly. But obviously இந்த காஸ்ட் காஸ்ட்லினா ரிப்பேர் ஆயிட்டு நின்றுச்சுன்னா அது இன்னும் காஸ்ட்லியா இருக்கும்ல. That's why this seems to be better. So inspection, yes, it will be periodically done on equipments, machinery. They'll check what are the conditions underlying so that it is not going for the breakdown level or not creating any harmful depreciations. Record keeping is important. You have to record what are the failures happening, when did you change the spare parts, all the records will be taken in. Consequences, obviously, consequences means what? Impact, positive angle, positive impact. Okay. So it will reduce the unanticipated breakdowns. Probably the equipment will be available more. எனக்கு வந்து ரெடியாகவே இருக்கும் எப்பவுமே. Then maintains optimum productive efficiency, reduces the work content of maintenance job and increases productivity and safety. Beautiful point. Probably can make this as another one single point also. Safety of worker. Okay. Evaluation of work done. Yes, you may expect this as theory question. We don't have problems in this. You may expect this as theory question directly. How you do this in an analytical approach? In a preventive maintenance proper பண்ணலாம்ல அதுல தப்பாயிடக்கூடாதுல்ல. So how you do this? You check how many inspections scheduled. For example, 100 inspection scheduled. How many are incomplete? So probably 7 are incomplete. So how much percentage is this one? 7%. If this work means what? Inspections incomplete divided by inspection schedule. Here I am taking a 7%. If it is less than 10% means yes, you are doing it better. Preventive maintenance is not better. First one. Performance of the department probably hours work for maintenance divided by scheduled tasks they will check. So in the performance section, நம்ம எவ்வளவு தூரம் work பண்ணிருக்கோம். Downtime. So downtime is available machine hours with respect to downtime in hours. So downtime in hours divided by available machine hours. How you get the available machine hours is you go for the working days into hours. So usually out of 30 days we work for 24 days. Okay, so 24 days into number of hours. Usually 8 hours. Usually 8 hours, but they'll be giving in the question, but usually this is not asked. So 8 hours a day into number of machines. I have 10 machines. So this is how we calculate the available hours. Available machine hours. Frequency of breakdowns. So available machine hours with respect to number of breakdowns with respect to available machine hours. Effectiveness of planning. Probably this can be considered with respect to labor hours or with respect to downtime. If you are considering labor hours means labor hours on scheduled maintenance with respect to total labor hours spent on maintenance. Scheduled because we are talking about preventive maintenance. Scheduled maintenance divided by total labor hours spent on maintenance. And with respect to downtime, if you are checking that downtime due to scheduled maintenance divided by downtime due to total maintenance. So I have 5 points how you can analytically do this, analyze this. Objectives, we can maintain maximum availability of the plant so that we are avoiding the breakdown and all. And proper condition of the machine will be maintained so that we can get the quality of the product. Yes, this is not compromisable. And you can minimize the wear and tear, the obsolescence and all. Then you can ensure the safety of the workers. You can keep the plant at the maximum the production efficiency, and you can achieve all the objectives in both economic and efficient. That's sort of economic of things. Advantages, more or less the same, so I'm not repeating. You can compare with breakdown methods, probably you may expect this in your question. The average downtime and its cost will be less compared to the average time taken to carry out. So you have to take to that particular area where the machineries will be taken care of, then you have to detect the repairs and all. And it enables the repair to be performed during a scheduled idle time. So the machine is not going to make idle hours in between. Okay, the machine will be running and will be having some particular time where the machine will be made according. Okay, so it will be a scheduled idle time, so we are not going to lose it. The line of balance will be maintained and the bottleneck also will be maintained. So we are not going to lose anything. So that's about the highlight of this. I think 7.2 is we'll just go through routine maintenance. Okay, routine maintenance also one type of maintenance. See, actually, we have gone. First one is breakdown. Only during the repair time we'll make it. Okay. Second one is why we need to wait for the repair to happen. We'll take some preventive measures. That's about preventive maintenance. What about routine maintenance is actually we'll plan the shutdowns, pre-planned schedules. Then probably the equipment will be running sometimes or during the pre-planned schedules we'll work for it. Okay. So that's about routine maintenance. The difference between routine and preventive is will check regularly. Regular inspections will be here. Here they will not be like regular inspections, more or less the same thing, but will periodically inspect and cleaning, lubrication, this or all will be done. Under preventive maintenance will not do the lubrication work. Actually, classically, the preventive maintenance where you routine where you discuss, but more or less some concepts will be overlapping. And sometimes will be doing replacement also in the case of routine maintenance. So includes lubrication, periodic overhauling, cleaning, all the works will be undertaken so that you can keep the machine in effective condition. And the timings of maintenance are decided at once. So maintenance techniques, yeah, please head is one of the beautiful heading because we will plan for the standby missions. Okay. So that the cost of loss and inconvenience will be reduced. So this is the main objective. What is the action needed? Once the original equipment fails, then the standard facility will be employed about interruption. Probably we have generators and inverters like so power shutdown. We have an alternative so that the work will be going on and will not lose anything. So to reduce the loss due to the breakdown maintenance, we do it. Okay. But the problem here is எத்தனை standby machine வச்சுக்கிறது எவ்வளவு நேரத்துக்கு வேணும் see that one single machine itself is very costly. How can you have another alternative? Okay. So factors probably have to check on capital investment. That's what I was telling. Next on the space, space is a very big thing. You cannot completely change the whole thing to the machinery. If the machinery is movable nature, then this machine probably the process is happening over here. Okay, and just let me draw a rough figure like the process is happening over here. Okay, this machine is under breakdown. Okay, probably I'm talking about breakdown. Then we'll be planning about the standby missions. So when we plan about the standby missions, we are talking about routine maintenance. Okay. So in the machine in the machine if the machine is movable in nature. If the machine is not movable in nature, then you cannot replace the machine. So what do you have to do? We have to change the pathway. So instead of going this way, we cannot go this way hereafter. You have to travel this way. So unnecessary the links break down or everything will be damaged. So that's one problem. Okay, standby missions it's not so very easy. So space is needed. And when we talk about standby missions, most of the time it might not be needed, but it's a depreciating asset. Obviously, I don't have check on. And periodic checking has to be done for the standby missions. Inverter வாங்கி வைக்கிறீங்கன்னா அந்த இன்வெர்டர் எப்ப தெரியுமா ஓடலாம் தெரியும் கரண்ட் போனது தான் உங்களுக்கு தெரியும். So this will happen. Okay. So benefits protection against a complete protection against a complete shutdown or shutdown of operations will be helpful. Okay, so everything is shut down, you can use of can make a use of it. Avoid loss of production. Probably when you go for any failures, you can assess and you can go for loss of production. Shifting production during breakdown. So it's an alternate form. So shifting production during breakdowns. You can alternate go for instead of standby machines, you can plan this one. So in this case, what we'll do is spare capacity will be maintained, not in the form of standby machines, we'll have spare capacity. So if one production in a production line requires shutdown, the output is maintained by shifting to underutilized machines. So we'll have some two or three machines, so that machine will be used. Capacities of different machines must be properly matched. Then you cannot talk about bottleneck only. That's no problem. Maintenance organization. So we'll be talking about this department where 15 to 60% of the investment will be planning on building and production facilities only. So you need to know how much you're going to spend on the standby missions of the specs. So what is the role of the maintenance department here? Is they will clearly check who is taking care of which one. So clear division of authority will be there. Vertical lines of authority will be there. They'll keep a span of control. Like 3 to 6 will be there for under one manager there will be 3 to 6. As I was saying, my cousin is working in L&D. He says that he has 100 plus engineers under his control, but it's not they are not directly under his control. So I'll name him as C because cousin I name him as C. So under him, there are totally like I remember he said some 4 or 5 years back I was talking with him. He said 150 engineers are there in one factory unit alone. I'm not talking about the whole L&T. One factory unit alone, 150 engineers. Okay, laborers. Okay, so there will be like different teams there. 3 or 4 teams I remember. ஒவ்வொரு டீம்லயும் வந்து 25 to 50 வரைக்கும் இருப்பாங்க. ஓகே அதுல வந்து ஒரு லீடர். ஸோ இதுக்குள்ள டீமா பிரேக் ஆகும். So like this, for one manager, there will be 3 to 6. Okay. Yes, it's obviously flexible because when you talk about maintenance department, if this department is free, they'll be called up to work on the missions. Okay. And they'll be designed to suit the types of maintenance work involved because all will not be involved in all the things. And depending on the need, the maintenance activity may be centralized or decentralized. Okay. As I was telling, he said that 150 workers are below him, 150 engineers are below him, which means he was talking in a centralized manner. So, or 5 workers வேணும்னா he'll be informing a manager, they will be allotting 5 minutes. So this person, Mr. C, is having the control of all the teams. Okay. So this is what you call a centralization. We can talk about decentralization also. So chief plant engineer will be there. Then there will be different departments like work service, maintenance workshop, safety engineering. They will be working only on safety. Or what he பேசும்போது he was telling, uh, like he was hearing a different sound. இங்கேயுமே சவுண்டு தான் இருக்கும். பட் அந்த டிஃப்ரெண்ட் சவுண்ட் கேட்டோம்னா he immediately reached that mission. ஆக்சுவலா அந்த மிஷன் வந்து எவ்வளவுனா 2 கிலோமீட்டர்ஸ் தள்ளி இருக்கு அந்த ஃபேக்டரிக்குள்ளே. ஸோ he was given some vehicle like அந்த pressing டைப் மாதிரி இருக்கும், லைக் ஸ்கேட்டிங் வெஹிக்கல் மாதிரி இருக்கும். He was given that vehicle. அந்த 2 கிலோமீட்டர்ஸ் போகணும். he rushed on a speed, கிட்டத்தட்ட ஒரு 60 கிலோமீட்டர் ஸ்பீட்ல போயிருக்காரு ஃபேக்டரிக்குள்ள. போயிருக்காரு. he was able to save one person's life. சின்ன சவுண்ட் வச்சு கண்டுபிடிச்சு போயிருக்காரு. he was appreciated for the safety engineering so very. Okay, so he'll be இங்க பாருங்களேன், இது கீழே டிவிஷன்ஸே இருக்காது. So safety engineering is so very important. Maintenance engineering is obviously when you talk about maintenance, you talk about maintenance contracts. So we'll have different teams on the planning, servicing, and different shops will be there. And maintenance stores and spare parts. So there'll be a stock maintained and they'll be getting all the records and other things. Okay. So when you talk about maintenance workshop, we can talk about overhauling, fabrication, electrical repair work, planning and drawing office. When you talk about planning, operations, maintenance. When you talk about shops, breakdown shops or preventive shops. Okay. So இதெல்லாம் important. 3 rules for organizing maintenance work. So we'll have a maintenance request. So they'll write to a central point saying that we need to go for this maintenance and all. Then only with the knowledge and approval of the maintenance supervision, the work will be carried on. And consequently, if they are not following, means they are actually not using the manpower properly. So they have to properly schedule everything. Then after the request is received, they go for maintenance store. The backup service will be there. Everything will be provided. Probably they'll check what are the spare parts to be made because you cannot maintain all the spare parts. And the spare parts are the lifetime of the 2 years are gone. 2 years கூட வச்சுக்கிட்டு வேஸ்ட் தான் வச்சுக்கணும். சம்டைம்ஸ் ஸ்பேர் பார்ட்ஸ் வாங்கினா 10 days யூஸ் பண்ண முடியும்னா வச்சுக்கிட்டே வேஸ்ட் தான். ஸோ அந்த மாதிரி இருக்கும். So in this case, like some vital spare parts are not available means there will be excessive shutdown means you have to shut down the plant. அப்ப நீங்க என்ன பிளான் பண்ணணும்னா, even though the spare parts may be available, you cannot wait for the spare parts to make available. அப்போ வந்து நீங்க replacement போடுறது better. Probably for sometimes the machinery will go absolute outdated ஆயிடும். Outdated ஆனதுக்கு spare parts கிடைக்காது. So there will be one central point all over India. One central point இருக்கும். அங்கிருந்து வர வைக்கணும்னா take a long time. அதனால நீங்க absolute machine வந்து மாறிடுறது better. Okay. So involves investing valuable funds because we have to talk about additional capital investment and records. We have to maintain the paperwork. Obviously, it has to be maintained. So definitely, you have to maintain this good maintenance work. Means you need to have a proper timetable and everything has to be done. We'll have history cards, logbooks, and all. So in the plant again, the history cards means like chronological order. When it is being serviced, when it is being spare parts checked, and etc. etc. It will include all the material costs, components replaced, what is the time spent, yes, how many hours spent, everything is needed. And for proper planning and control, you have to do. Factors for effective maintenance is good supervision and administration is needed. Clear instruction has to be provided. Proper control of work should be there. Good training should be provided to the maintenance people, maintenance personnel. Proper scheduled program should be there. Proper maintenance record should be maintained and adequate stock of spare parts, particularly insurance. It's all needed. Maintenance problem is obviously are going to minimize the overall cost of maintenance without sacrificing the objectives. So what we do is we go for two alternatives. One is you repair the machine or equipment only when it breaks down or replace the equipment. Okay, usually in the exam often repeated one. What are the two alternatives means? We'll check whether machinery and the cost later will work out. Okay, the machine break out on the phone. Else what will do it? We replace it. Okay, you need not wait for the expiry date for the machine. You just replace it. Okay. But when you go for replacing the equipment, you will not directly replace. You will check for the repairs, what are the things, how it is being shutting down. Then you will go for replacing them. Now, buying the machine is a capital investment. You cannot directly go and say replace it. So that has to be taken. Okay. And what is the cost involved here is actually I talk about two types. One is premature replacement, which means the expiry life is there. Okay, depreciation zero on cost of value is zero. அந்த மீனிங் வந்து வெயிட் பண்ண முடியாது. ப்ரீமெச்சுவர் ரீப்ளேஸ்மெண்ட் பண்ணி ஆகணும், காஸ்ட் ஆஃப் பிரேக் டவுன் பண்ணி ஆகணும். So balancing this is what you call optimal. Okay. So methodology is you go for the judicious combination. This one or that one. So relationship between preventive maintenance and repair time also will be helpful. So how far it? So that's suppose 7.4 replacement of machines. When will you replace? Wear and tear. Okay. இது மேல வேலைக்கு ஆகாது. எத்தனை வாட்டி ஓவர்ஹால் பண்றது? and sometimes it gets outdated. There is a need because of technology change or whatever it is. There is a need. It is becoming outdated. Obsolescence means outdated. Okay, absolutely. So wear and tear is a primary concerning while you design the appliances, probably because of passage of time or normal usage of plant condition is running and running all the time. So we have to go for another machinery. Obsolescence is a major danger because we are in the modern era. Tech is changing so much. You have to go for. So it's a major issue in the procurement and installation of machinery and all. And when you talk about completely with respect to technical obsolescence, another machine can do the same job more efficiently. Okay, that's about we are talking about semi-automatic and automatic machines. Will with reduced time and also at a lower cost. Reasons may be like continuously or working on the improvement methods and the techniques of production also. And there is a very fast rate of improvement so that you have to replace the machinery before its expected life, which means you are compelled to do that. Okay. Probably we were discussing about the Mahindra and Mahindra case. When you go for technical side, they say we use the state of art technology. State of art technology வந்து எல்லாரும் யூஸ் பண்ண மாட்டாங்க வேர்ல்ட் வைட்ல இருக்கிற டெக்னாலஜி நம்ம யூஸ் பண்ணிட்டு இருக்கோம் அப்படின்னு சொல்லிட்டு so state of art technology we have to go and go along with that is it not compete with the global market okay necessity is reducing the running cost of the concerned machine and new machines productivity will be more that's why I'm trying to go for the better one expected problem so we have to decide whether you have to replace the machinery at present or what's now what to in the future okay justification check whether it's absolute or deteriorated. Obsolescence means no other go. Deterioration means obviously to that equal range you can buy a machine. Whether we can check operating cost may be minimized and productivity might be increased. So we'll check all the factors. We'll go for the technical factors. What is the standpoint of rate, speed, accuracy, strength, rigidity, எவ்வளவு தூரம் இருக்கு, output எவ்வளவு தருது, capacity எவ்வளவு அதெல்லாமே பார்ப்போம். Obsolescence and equipment worn-out condition. A special advantage of any new machine is there. Okay, sometimes we go for a new machine and that gives a many more advantages. So let us go for that. Flexibility and versatility of the machine also gives. Cost factor also has to be checked as cost accountants, our nature of job will be here only. Okay, so probably in any field you go, when you go for manufacturing side, any job nature in manufacturing side, you'll be focusing on this one. Whether you're going to buy new machinery or which is what high repair costs may be there because the existing machine is not working properly. High remodeling costs. Sometimes you need to go for remodeling the structure of the machine, then you have to spend more. Less chance of spoilage and rejection work. So probably if you go for new machinery, probably it will work in a better way. Okay, in that sense. Faster rate of production. Okay. Per minute, it can make up to 60 units. So, per minute, 60 units means 1 second, or unit is allowed, and let me go for this one. Earlier, it was making only 45 units. Now it is 60 units. Then definitely it's going to lower my cost because time is reduced. The labor cost also may be reduced. Compactness of the machine. Yeah, beautiful pump. ரொம்ப பெருசா இருக்கு அதுக்கு பதிலா ஒரு மிஷின் ஒரு ரூம் சைஸ்ல இருக்கும் 10 by 10 by 10 ரூம் சைஸ்ல இருக்கும் அதுக்கு பதிலா சின்னதா ஒரு மிஷின் வருது சேவிங் ஸ்பேஸ் இட்ஸ் a very highlighted one and flexibility and versatility and yes eighth one availability of funds how far you can manage with the funds இதெல்லாமே பார்த்துட்டு ஃபண்ட் இல்லைன்னா okay so replacement programs probably what they do is every year out of the earnings of the company they will allocate a certain percentage to replace the machine in the future. Okay, when your industry is primarily working on manufacturing sector, then you have to plan for all these ups and downs. Okay, and replacement is made of the oldest and the most inadequate machine only. Okay, and it's based on the economic of the working conditions. Okay, so this also has to be checked. So let me continue. Spare parts management 7.5. So far we are talking about maintenance. Now this fifth heading is about spare parts. So it's a complex activity. You need to know what are the spares needed and different product life cycle. என்னென்ன several stages இருக்கு அது பேஸ் பண்ணி என்ன product என்ன spare parts வேணும். So when we talk about SPM, so this is in short called as SPM. It deals with two types of parts. One is fast moving, okay, one and two. One is slow moving, or what you call as non-moving. Fast moving frequently will be needing it. So the manager has to keep a stock on that. When you talk about slow moving or non moving spare parts, it's very rarely used. Probably it's a great challenge that the manager has to properly schedule it. Okay, எப்போ replace பண்ணாலும் proper so you'll be maintaining a database management system of how far, see, you might be holding the stock, the spare parts in stock. but it becomes technologically absolute. அப்ப யூஸே இல்லாம எதுவும் மெயின்டைன் பண்ணணும். அப்போ வந்து மெயின்டைன் பண்ணாம இருக்கிறது better. And like product differentiation also. Some consumer preferences are varying, then why you need to maintain? So there is some methodological record-based approach also where you provide service to the customers which products you need and all. And yes, please highlight this purpose is needed for preventive maintenance. So when you talk about preventive maintenance, we'll be holding this purpose management also. So probably usage, we have to keep the records for specific and general purpose spare parts. What is used in preventive and breakdown maintenance? We have to track the movement of the spare parts, how the consumption is done, what about the future maintenance activities, whether it's based on short term or mid term. Depending on that, you have to plan for it, and you have to forecast the demand for spare parts also, whether you have to maintain for medium term or long term. And you plan for collaboration with spare part vendors. So they become the suppliers in that case. Okay, optimize the spare parts inventory. So you know about the UQ model, economic batch quantity model, economic order quantity model. This is we are working for the raw materials and inventory, but here we have to work on the same angle for spare parts inventories. Okay. Why spare parts is when we talk about preventive maintenance, we are talking about spare part management. So preventive maintenance is very important. So spare parts also it plays important role here. Okay. So analysis, we have to analyze. That's what about demand forecasting, like spare parts forecasting will do. Classification of spares. Yes, this you may expect in one word questions. Classified maybe as per the service level or the stocking list. Okay. Regular spares, probably they need it regularly in substantial number. Both reliability and per cost of units are will be less. Usually they'll go for measuring the service level. So probably you check the opportunity cost of understock of one item and overstock of one item. ஸோ ஒரு யூனிட் அதிகமாக வச்சிருக்கனால என்ன ஒரு லெவல் அண்ட் கம்மியாக இருக்கனால என்ன ஸோ ஓவர் ஸ்டாக் ஆஃப் ஒன் ஐட்டம் அண்ட் டிவைடட் பை ஓவர் அண்டர் ஸ்டாக் ஆஃப் ஒன் ஐட்டம் ஓகே ஸோ தட்ஸ் அபவுட் ஆஸ் பர் சர்வீஸ் லெவல் ஆர் அண்டர் ஸ்டாக்கிங் காஸ்ட் தட்ஸ் வை வி கம்பேர் திஸ் வித் அண்டர் ஸ்டாக்கிங் ஆஃப் ஒன் ஓகே then you will go for insurance pass. So insurance pass probably it will work only during this period of time. After that, you cannot expect that to work. So it's actually making a loss. Sometimes we have to talk about capital spares. Capital spares means you cannot make the equipment to shut down long time. So it's not like small spare parts we are talking about. It's about the capital spare parts where there is a chance of failure. Then you have to go for complete replacement of machinery also. Probably there is a sacrifice. And rotatable spares, yeah, this is beautiful concept. Some plans and assets will be periodically changed. You have to change it periodically. அப்பதான் நல்லா work பண்ணும். அந்த மாதிரி இருக்கு. So how you manage this one and how you take the proper control, these are all normal life only, so I'm not going one by one. First problem, there is two say has a mean time between failure. In short, we call this as MTBF of 30 hours and has a mean time to repair MTTR of 5 hours. What do you mean by mean time between failures? The machine will be working on and on and on for how many hours? Definitely mean time. Average time calculated based on the past experience. So it will be working for 30 hours. Definitely, okay. Probably if it goes for repair, so probably at this point of time it is going for repair. Okay. See, they say it's 30 hours. It may work for more than 30 hours also or less than 30 hours also. We usually say 30 hours. If it goes for repair, then it's a break, right? Which means it's taking some time. The experts has to work on that machine. How long it will take for them to work? 5 hours. So that's about the data given. So there are two products, product A, product B. Mean time between failure for product A is given to be 30 hours, whereas product B is given to be 40 hours. And mean time to repair is given to be 5 hours, and here is given to be 2 hours. Okay. First question is which product has higher reliability? இந்த மிஷினை ஆன் பண்ணா எவ்வளவு நேரம் கம்ஃபர்டபுளா ஓடும் 30 hours 40 hours 40 hours is more comfortable. So mission B is having higher reliability. So you just remember instead of having a mission you have a bike. You want to go for a long drive. எந்த பைக் எடுப்பீங்க பைக் ஏ பைக் பியா பைக் பி 40 hours ஓடும். Instead of us you make it as kilometers 40 kilometers தைரியமா போகலாம். So you go for bike B. Then go for second one, which has greater maintainability. Okay, which has greater maintainability means this, if you talk about repairs, this will go for 5 hours, this will go for 2 hours. 2 hours means less number of time. Now, சரி பண்ணிடலாம் About mission B is also having greater maintainability. Third one, which product has greater availability? Here I have to go for comparison. Out of 35 hours, why I say 35 is total is 35 hours. The machine working and put to repair. Out of 35 hours, 30 hours it will be made available. This is for mission A. Whereas if we go for mission B, this is 42, right? Out of 42 hours, 40 hours I can make it available. So which is better? Can I get it percentage? Can I get the value, please? This is 85 something, 30, 35. This is 85 something, is a 98 for the one. Check one. 85.7 now. Okay, I'll keep it for two decimals. And this one 40 divided by this 40 divided by 42, 95.24. So this is having great availability. So that's about the first question now. Probably you may expect the same values with the same concept, or the values might be a bit differing. So probably instead of this 2 hours or 5 hours, we might be changing some values. So you can please make a note of it. So this is problem number. Now let me go for problem number 2. Can you just go for the head? Now the question on the book. Question number 2. A computer system has 2000 transistors which are subject to random failure. I want to highlight this word random failure. Echo failure ஆகும். It's not like ஒன்று fail ஆச்சுன்னா எல்லாமே fail ஆகுது அந்த மாதிரி இல்லை. It can fail at any time. Okay. And the probability pattern is given below. Please try to understand this table. I place a star mark. It's quite important to understand this table. At the first month end, I want to highlight this word. At the first month end, there's a probability that 10% of the transistors might get failed. So how many transistors are there? 2000. Among this 2000, 10% may fail. So its failure to date is given. So at the end of 2 months, totally how many fail? Totally 25% may fail. So it's inclusive first month and second month together, 25% may fail. Then if you go for the third month end, 45%. If you go for the fourth month end, it's given in percentage. That's why I'm using the word percentage here. 75%. At the end of fifth month, 90%. Yes, at the end of 6 months, always should. Okay. So if the failed transistors are replaced individually, okay, please be careful with the words. If the failed transistors are replaced individually, for example, I am in the second month. How many has failed? 25 has failed. So why I need to wait for another 4 months to replace everything? So let me replace now itself. And I know okay, so let me replace it now itself. So as and when they fail, the cost per replacement is 18 rupees plus 12 rupees for cost of downtime. So you know what is downtime. So you're waiting for that to make it for happen. So what's the cost when you go for individual replacement? This is what you call as individual replacement. When you talk about individual replacement, actually you have to spend the cost per replacement, cost for one transistor. Cost per transistor is 18 rupees. And you have to make it happen to work, which means downtime cost. Downtime cost is 12 rupees of 12 rupees. So totally for individual replacement per transistor is 30 rupees. Whereas if you talk about the alternative method, it says if all the transistors are replaced in one lot, so obviously at the end of 6 months, all the transistors will fail. We are not talking about the end of 6 months. We are talking in between period, like 4 months or 3 months or whatever it is. So if you're planning to make it like periodically, you change it. Okay. Replacing one lot at periodic intervals and a few random failures may occur. So 6 months பிறகு வந்து மொத்தமா சேஞ்ச் பண்ணிடும் அதுக்கு பிறகு வந்து நடுவில் நடுவில் ரேண்டம் ஃபெயிலியர்ஸ் இண்டிவிஜுவல் வரும்போது சேஞ்ச் பண்ணும் அப்படின்னா the average cost of downtime in group replacement is only 2 rupees per transistor. Okay, just imagine you have 10 tubelets in your home and you don't know how to change the tubelet. This is for one thing. Or you talk about switches. One switch is not working. You call an electrician. He says, if I come for changing that one switch, you have to pay that 1 day's cost. The switch is costing maximum. If you go for a higher switch or smart switches, it may be costing 100 or 200 rupees. But the person, the expert person coming and changing the switch, you need to pay him 1500. Okay, he says another one system is almost like closing stage. So what do you do? கூப்பிட்டு கூப்பிட்டோம் 1500 செலவு பண்ணி மொத்தமா மாத்திர சொல்லுவோம் திரும்ப 1500 செலவு பண்ணுவோம். Same thing is happening over here. If you change the transistor, one transistor is 18 rupees. But if you change then required, you have to pay 12 rupees extra. But when you go for group replacement, he will come. Oh, the expert, the electrician will come. He'll change everything and go. So in that angle, if you check, you're going to change all the 2000 transistors. So it's not like 18, 20, 12 rupees. It's just 2 rupees per transistor. So if you consider in the same angle, if you go for alternative method, okay, alternative method is where you go for group replacement and then you'll go for individual replacement. So if you talk of this way, the cost per transistor you cannot change it. The market's 18 rupees now, you cannot change it. But the downtime cost, yes, you can minimize this value where it is 2 rupees. So instead of paying 30 rupees per transistor, you can just pay 20 rupees. But you have to check which method is better. Okay. So we'll work on this. Actually, they have given a probability value, so it may look somewhat like a probability problem. So you can please join with me. Yes, can you please join with me? So let me have the columns for working. Actually, this is involving some logical calculation. Okay, calculation tough and all that, we have to go for logical calculation. So let me have the month, first month, second month, third month, fourth month, fifth month, and so on. Okay, 6 months are there. I'll be going one by one only. Then we'll go for the probability value. So what's the probability value for first month? It's actually see. This one I just wanted to make a note of it. It's given 10, 25 weeks. It's actually 0.1, 0.25. Am I right? Because we have, when you write in terms of probability, the total probability is 1. So we have to write in decimals. So 0.25, 0.45. And when we talk about 1 month, see, this is 0.1, this is 0.25. So shift from 1 month to second month is actually they are giving cumulative value. They have given cumulative value. So shift from 1 month to next month is only 0.15. Why? At the first month end, it's 10. At the second month end, it's 25. So when you shift from 1 month to next month, here is 10, here is 25. So what's the difference? Only 15 is the difference. So the output will be 0.10, 0.15. Is it okay? What's the next value? Is shifting to 45. So 0.20, then is shifting to 75, which is 0.30, then is shifting to 90. 0.15, then is shifting to 100. So at the end of 6 months is 0. That's 1. Completely 1, right? So this is 0.1. Okay. So if you add, you'll get the 1. So total probability is always 1. So we'll take the probability value. Then we'll go for number of replacements. Okay, we'll go for number of replacements. Talk about number of replacements. Okay. Yes. First month then, how many will be the failure bar? 10%, 0.1. So 0.1 will be the failure. Totally, how many transistors you have? 2000 transistors will have. So you add one more column more. I need so much of space, that's why I'm taking a lengthy, wider column here. So we'll take one more column for number of transistors. Number of transistors. So it's only 0.10, that is 10% of 2000. So how many will be a failure? 200 will be the failure. Okay. Then we go for the second month. Please, we have to check logically. You are in the second month, how many will be the failure? 0.15 will be the failure. But you have changed to 200 transistors and 1 month is now old. And the 200 transistors are 1 month old. Another 10% will be a failure. Am I right? So this 0.10 transistors replaced will have a failure of 0.10. Okay. So what's the value here? This total value 0.16. 0.10 plus 0.01. So 0.16. So 0.16 of 2000, 320 I think. Is it okay? 16% of 2000. Now let me go for third month. When I talk about third month, there is a current failure of 0.20. Okay, this is current failure. Let me write C. Plus the number of units which you changed, 0.16. This is now 1 month old. So 1 month old means there's a loss of probability of 0.10 plus the number of units which you change in the very first month beginning, 0.10. That is now 2 months old. Now 2 months old means what's the probability? 0.15. So 0.15 into 0.10. Valid. Online able to manage it? Valid. 0.23. 462. Likewise, we proceed for remaining. Okay. Let me go for fourth year. Please online join for the fourth year. Okay. Fourth year, at currently we are in fourth year. Let me change the color. At currently we are in fourth year. What is the failure? 0.30. So 0.30 plus. When you talk about the number of replacements done in the third month, 0.23% is done. Okay, sorry, 23% is done, 0.23. This 0.23 replaces now 1 month old. Okay, so first month over, second month over, third month over, you are in the fourth month now. Fourth month, currently there is a probability of 30% loss, that is 30% failure, so 0.30 plus in the third month, you replaced 23%. See, that's how we got this value 23%. And now that is 1 month old because only not 1 year, 1 month. Because that you replaced one just a month before. So 1 month old. So what's the probability of 1 month old? 0.10. So 0.10 into 0.23. Now 0.16 is the second month end you replaced. Okay. Now that is 2 months old. 2 months old probability is 0.15. So 0.15 into 0.16. Okay. Plus the very first month you replace 0.10 and now that is 4 months old. Here you replaced 0.10. Now 1, 2, 3, 3 months old. So 3 months old probability is 0.20. So 0.20 into 0.10. Okay. Can you please check the value? Online is it clear now? Yeah. Value. 0.37 now. 0.37. This is 734. Okay. Actually, I did it in Excel sheet. There may be some small variations. Okay, no issues. Let me continue with respect to fifth one. Let me continue for the fifth one. Fifth period, fifth month. What's the fifth month probability? I think 0.15, I think. So 0.15. So current month probability is 0.15 plus previous month it was 0.37. It is 1 month old. 1 month probability is 0.10. So multiply that. Then go for the 0.23 value. So 0.23. That is now 2 months old. For 2 months it is 0.15. Okay. Plus now go for this value. 0.16. 0.16. That is 3 months old. So 3 months means 0.20. So 0.20 into this value. Plus the very first month replaces 0.10 number of units. And now that is 4 months old. 4 month probability is 0.30. You have to calculate it. Okay. So probably you get 0.28. This value will be 0.28. You can please check. 560. Make 560. Yeah. Let me go for the 6th month value. Please join for sixth month. Sixth month probability is 0.10. So current probability is 0.10. Then you changed 0.28 units the month before, and the probability for 1 month failure is 0.10. Okay, plus 0.37, 0.37 over here, and that is now 2 months old. Okay, 2 months old is 0.15. Then the earlier to that is 0.23, and now that is 2 months older, 3 months old. So 0.20 plus 0.16, and that now is 1, 2, 3, 4 months old. So 0.30 plus the very first replacement is 0.10, and that's 5 months old. So 0.15. Okay. So the total value, please check that they are getting 0.29. 580. Seventh month. When you talk about seventh month, actually the property is not given. Okay. Uh, till the month end only they have given. They are not talking about the seventh month property, but we will work out the seventh month because we need to check because it's going to work only for 6 months. After that, we are going to replace. But few elements we have replaced now and then, right? First month கொஞ்சம் ரீப்ளேஸ் பண்ணிருக்கோம் செகண்ட் மந்த் ஸோ அதுக்கெல்லாமே வந்து இன்னொரு 6 months வேலிடிட்டி இருக்கும்ல ஸோ அந்த பேசிஸ்ல we're going to work on seven. So 7 month currently is not given, so we'll work from the past replacement. So 0.29. So probably I'll start from here. Okay, 0.29. That's the latest number of units we changed, and that is now how many months old? 1 month old. So I have to take 0.10 into 0.29. Then the earlier to that is 0.28, and that now is 2 months old. 2 months means I think 0.15. So 0.15 into 0.28 plus earlier to that is 0.37, and now that is 2 months old. 2 months means 0.2 months or 3 months, but 3 months. So 0.30. 0.0. So 0.16 divided by 0.16 plus 1, 3, 4, so 0.30. So it's not the truth. Thank you. Then the very first changed is 0.10, and now that is 6 months, so 0.10. Okay, 0.15. Sorry, I left out something. 0.23 I left out. Sorry. 2837. Here is 23. 23. Then 16, which is 0.15 probability. At last 0.10. That's having a probability of 1 month. Sorry, 6 months. So 0.10. So what's the total here? 0.25. Okay. So there is a total number of units to be changed is 496 units. We will now go for finding the cumulative value of number of items to be replaced. Cumulative is just we added because we are going to go for average. See, there is one question arising: why I am checking month by month and cumulating all the values? Why cumulative? You are going to find overall average value. When you talk about active, see, in the earlier problem also we were talking about mean time between failure, mean time to repairs. Whenever we talk about optimality, we go overall checking with respect to average value. So that's why we go for cumulative values, then we average it. So you know the average formula, right? Average number, sum divided by total number. So that's why we do it. Okay. So cumulative number of values. This is 200. Cumulative 550. Sorry, 520. Then cumulative 462. So it's 982. 82 or 62? 82. So I wrote it on the. Then 734, 17167, then 560, 2276, 580, 2856, then 3352. Okay. So these number of replacements we require. When we talk about this column, it happens like at the first month end, at the second month end, and so on. Now we'll go for calculation part. So already we were talking with respect to number of replacements. You remember, for individual replacement, we are going to spend 30 rupees per transistor. For group replacement, we'll be spending 20 rupees per transistor. Okay. So we'll go for first category. So number of period is 1, 2, 3, 4, 5, 6. Actually, there is 6, but we have calculated 7 also. Okay. Then the cumulative values. Here is 200, 520, 982, 1716, 2276, 2856, and 3352. This I'm copying from the earlier table. Now we'll go for with respect to breakdown maintenance. So breakdown maintenance is whenever it occurs, we replace it. So with the help of this value, we'll go for monthly breakdown value. So it's 200 transistors. For one transistor, it's 30 rupees. So 200 into 30, 6,000. Okay, right? Then 720 transistors into 30, how much? 720 into 30. This is actually for 2 months. So you have to divide it because you're doing monthly. Okay, so this is monthly. So actually we're getting how much you are getting? 15,600. 15,600 divided by 2 so that you get 7,800. You should not forget this one. Okay. Then this is 982 into 30 divided by 3 months. 98201. Please check. Yeah. Then 1716 number of transistors, each 30 rupees for 4 months. 12,870. Then 2276 transistors, 30 rupees each divided for 5 months. So it's 13,656. 2856 transistors, each 30 rupees for 6 months. 14,280. 3352 transistors, 30 rupees each for 7 months. So it's 14,466. Okay, so this we are working on with respect to individual replacement. Now we'll go for preventive maintenance, monthly preventive maintenance. Okay, when you go for preventive maintenance, it's directly you replace it, go for group replacement, replace everything. So how many transistors we have? 2000 into 20 times. So if it is the first month, it's 2000 into 20 directly, I think 40,000. Okay. We go for second month, it's 40,000. For 2 months, you're doing it at the end of 2 months. So it's divided by 2. So it's 20,000. If you go for 3 months, 40,000 divided by 3. It's 3333. Am I right? For 4 months, 40,000 divided by 4. So 10,000. For 5 months, 40,000 divided by 5. 8,000. For 6 months, 40,000 divided by 6. So 6667. 7 months, 40,000 divided by 7, 5715. Is it okay? Now we'll go for total cost. So what's the total cost? Add this column, add this column. So this is 46,000. This you are working monthly on. So you need not divide over here. Already divide money 2 months, 2 months divide money. So directly you can add the final value 7,800 and 20,000. So this is 27,800. This is 23,153. Am I right? 153. Yeah. And this is 32,000. Sorry, 22,870. And this is 21,656. This is 20,947 and 20,000. So group replacement will be better at this 7th month. Okay, why we say this is 7th month is better? See, already in the question they have said at the end of 6 months, all will come to failure because in the question we have this is 100% probability, right? Here we are taking. See this one. Here it says at the end of 6 months, it's 100% probability that everything will fail. Our question was whether to go for group replacement or individual replacement. If we are replacing, especially with respect to group replacement, we are going to group replacement in between the 6 months or end of the months. So probably if you look out these values, it decreases, and it still decreases. Okay, it still decreases. Probably you can check for 8 months also. 8 months check now decrease ஆகும். But anyway, after the 6 months, you have to replace the why you have to go for 8 months. புரியுதா? எப்படினாலும் 6 months தான் அந்த வேலிடிட்டி இருக்கு. அது பிறகு க்ளோஸ் ஆகும்னா you did not check for 8 months. It's understood that you go carefully. We were checking whether in between it was doing what kind of job. அவ்வளவுதான். Okay, first thing I had to make a note. Secondly, when you talk about this individual replacement, see it was increasing. Increase ஆகிட்டே தான் போகுது. அப்போ எதுக்கு நீங்க individual replacement போனீங்க? It's waste. If you check for preventive maintenance, definitely it decrease. See, this is decreasing. This is actually increasing. It increasing. It is decreasing. Now there is a confusion. Which one is better? So overall checking at this point of time, we can decrease it. Completely you can go for decrease. So this one seems to be better. So that's about this question. So this topic is done. Okay. Thank you for thanks.